In 1-2 in Algebra 1, we're talking about algebraic expressions in this section. 1-1 was numerical expressions. 1-2 now involve algebra, variables. So we're still in this initial stage where we want to write a verbal expression. So we're going to reverse it. Before they gave us a verbal expression and we had to write a numerical or algebraic expression. Now we're provided the algebraic expression, we have to write a verbal expression. So this is going to be 4 times a quantity Q. Quantity Q. This can be 1/8 with fractions. We always put a little hyphen there. 1/8 of a number y. So notice the different ways of writing multiplication. This could be written as r more than 15. And hold on, I want to just grab something just to make sure. Yep, that's good. That's good. Yeah, I like that. We're going to write 24 less than a number W. The product, oh, look at that. The product of 3, we should write it 3 out, right? 3 out. Of 3 and a number squared. A number n, or how about and the square. The square of x. How are we going to do that? We can do let's do r to the fourth power divided by 9. Ooh, 6 more than twice a number. A. Here we go, r to the fourth again. The fourth power, let's change it up. The fourth power of r times t cubed. And let's do 25 plus 6 times a variable, a cubed, ooh, no, a squared times the square of x. Okay. Wow, we got lots of these here. All right. This is getting very. The product of 6 and a variable, is that f? Yeah, that's f. Ooh, okay. 6 times t squared let's actually move that a little bit. I'm going to change it up because I haven't done this. Let's do the sum. Let's do the sum of 6 times t squared and the product of 5 and f. That's not my best, but they're getting a little crazy here. Let's do let's do 3 times, well, not 3, let's write out 3, sorry. 3 times a to the 5th power divided by 2. And this one we're going to write, this is an interesting one, 9 times the difference of a squared and 1. All right. Oh, still more. All right. Well, we're going to be very well versed at this. 5 times 5 times a variable g. Let's not do that. I don't like that. I like the product. Probably separates it better. The product of 5 and the variable g to the 6th power. Let's do let's try the product again. Or what do we want to do? Multiply times. Yeah. Let's do, we'll stick with the product. I like the product. That's not a bad one. The product of, because we really set what the two products are. The product of c minus 2 and a variable d, or a quantity d. Variable D. And hopefully this is our last one. Let's take the product of 5 and H subtracted from 4. That was a good one. Oh, you got to be kidding me. How many more we got of these? Hi! Oh, goodness, we got 6 more. Okay, it's all right. We're getting good. We're definitely moving along here. All right. Twice the product twice. Can we do twice a variable b squared? Twice a variable b squared. That looks like we would do 2 times b and then quantity squared. So I need to do the b squared first, because orders of operation, we would need to do that first. So would 2 times the square of b? I like that. That separates it. 7 times x to the third minus, that's not how you spell minus, minus 1. The 4th power of p power of p plus 6 times r. Alrighty. So 3 times n squared Well, let's move that around a little bit. Let's use a different terminology. So I like x oh, no, let's do the difference of 3 times n squared and x. That worked. We're going to go back to the quantity. The quantity. Oh, no, let's the sum of. Yeah. The sum of 2 and 5 times p. And let's do the product of 18 and the sum of p and 5. All right. Writing an algebraic expression. I like this way better. To me, x more than 7, so 7 plus x. Remember, x more than, so we're going to do x more than 7. So 7 comes first. A number less 35. So a number, let's name it n minus 35, less 35. 5 times a number, 5 times x. 1/3 of a number, we can do 1/3 p, or you can do p divided by 3. Either of those work. 4 divided by f divided by 10. F divided by 10. The quotient, which means division, of 45 and r looks like that. 3 times a number plus 6. 3 times a number plus 16, excuse me, not 6, 16. 18 decreased by 3 times d. 18 decreased by 3d. See how much faster and easier? K squared minus 11. Minus 11. 20 divided by t to the 5th power. 20 divided by t to the 5th. The sum of a number and 10. The sum of a number and 10. So that's n plus 10. 15 less than. So 15 less than the sum of k and 2. So k plus 2 minus 15. We do not need parentheses. We don't need parentheses to say, hey, we need to do this first, because we would already do it first. So there are no need for parentheses in this one. That's a technical one. See if you got that one right. The product of 18 and q. 6 more than twice m. All right, well, we only had a short number of those, way less than the writing out ones. Example 4. So there are 1,024 bytes in a kilobyte. Write an expression that describes the number of bytes in a computer with n kilobytes. So for each kilobyte, it is equal to 1,024 bytes. So if we wanted to find out how many bytes there are, we would take the number of kilobytes times 1024. And you could write it also 1024 n times n. So both are okay. It doesn't matter about the order in the word problems. Howard Hughes, Professor Emeritus of Texas Wesleyan College, and his wife Erin Connor Hughes attended a record 6,136 theatrical shows. Write an expression for the average number of shows they attended per year if they accumulated the record over Y years. So we're going to take the number of shows in that timeline, and we're going to divide it by the number of years. And that would give us the average number of theatrical shows per year. So this is shows, years, Y years, and that's why we would get shows per year. So that was important to know. Attend per year, shows per year. So they want to know shows per year. So shows are in the numerator, years are in the denominator. The difference between high and low tides along the Maine coast 1 week is 19 feet on Monday and X feet on Tuesday. Write an expression to show the average difference between the tides for Monday and Tuesday. The average difference. Well, it's 19 feet divided by 2 is going to be the average of those two. So I would assume that's what they mean. The cost of a t-shirt is shown. $19.95. Monica has a $10 off coupon. Write an expression that describes the cost of t-shirts, not including sales tax. Okay, so we would have $19.95 times the number of t-shirts minus the $10. So you only get a one-time $10, not per t-shirt. Gym membership. Juliana wants to join a gym. The cost of a gym membership is a one-time $100 fee plus $30 per month. Write an expression that describes the cost of gym membership after M months. So if it's $30 per month plus the $100 membership fee, you would get 30 times m plus 100. The cost for bowling is $5 per player for shoe rentals and $45 per hour to book a lane. Suppose a group of F friends go bowling for H hours. Write an expression. So we have 5 times F, because that's the cost of shoes. This is the shoes. Plus, we're going to do 45 times H, which is the cost of the lane. So that's the lane cost. And that would be our formula. 5F plus 45H would be our total cost. Evaluate each expression. So now we're going to substitute. So my G value is 2 plus 6 times my T value, which is 11. Orders of operation, we're going to do multiplication, 66. And 2 plus 66 is 68. Evaluate each expression. 7 minus, when we have GR, that's G times R. The G value is 2 times the R value is 3. Now, we have subtraction and multiplication. Very important. What are we multiplying? We're multiplying negative 2 times 3. So we have 7. And then negative 2 times 3 is negative 6. So that sign tells me whether it's addition or subtraction, and we get 1. R squared, which is 3 squared, plus G cubed, 2 cubed, minus 8 to the 5th power. So we're going to do inside the parentheses. We have exponents and subtraction, so we're going to do the exponent first. 2 cubed is 8. 8 minus 8 is 0. Now we have 2 exponents. We're going to do left to right. So 3 squared is 9. 0 to the 5th is 0. So my answer is 9. The quantity of 2 times my T value, 11, plus 3 times my G value, which is 2, divided by 4. So we'll do inside the parentheses. We have multiplication, addition, multiplication. We'll do the multiplication. We'll do the other multiplication. We'll add. And then we'll divide. We'll substitute 11 squared plus 8 times 3 times T plus R squared. So we're going to do squares, 121 plus 8 times 3 times 11 plus 3 squared. We'll do the other square, 121 plus 8 times 3 times 11 plus 9. We'll do the multiplication left to right. 121 plus 24 times 11 plus 9. We'll do the other multiplication, which gives us 264 plus 9. Mr. Mack, how did you know 24 times 11 so quickly? Ask me about the 11 rule. And now we'll do the addition. So that's 5. That's 8, that's 385 plus 9, which gives us 394. Good problem. Lots of work there. 3 times G times the quantity G plus 3 squared minus 1. So we'll do inside the parentheses first. 3 times 2 times 5 squared minus 1. We'll do the exponent. 3 times 2 times 25 minus 1. We'll do multiplication. We'll do multiplication. And we will do subtraction. Good. A squared times B times C minus B squared. So we'll do the squared, we'll do the exponent, which is 64 times 4 times 16 minus 4 squared. We'll do the other exponent, which is, this is the opposite of 4 squared. So 4 squared is 16, so the opposite of 16 would be negative 16. We'll do the multiplication. 64 times 4, 16, 24, 256 times 16 minus 16. So we'll multiply that by 16. 36, that's 33, that's 12, that's 15. Move the place, 6, 5, 2, 6, 9, 10, 4. So 4096 minus 16 is 4080. So 4080. All right, I like it. Good, good. C is 16 squared minus divided by, it's a horrible square, divided by B, 4 squared, plus B squared, 4 squared, divided by A squared, 8 squared. So I'm not going to get these big numbers. I'm going to do something that is better. We have 16 times 16 over 4 times 4. And these can cancel. This cancels with that to make 4. This cancels with that to make 4. And we have 4 times 4, which is 16. And then I'm going to do that the same for 4 squared, which is 4 times 4, over 8 squared, which is 8 times 8. And these are going to cancel. 4 goes in 2 times, 4 goes into 8 2 times. And that leaves me with 1 over 4. Now we can, oh, that's plus, Mr. Mac, plus. Thought we were going to get away with something really nice. Plus, okay, so 16 and fourths. So 16 over 1 equals how many fourths? We're going to multiply by 4, and that's going to be 64 fourths. So that's going to switch to 64 fourths plus 1 fourth, which gives us 65 fourths. You don't have to turn it to a mixed number. That's not necessary. And we can leave it as 65 fourths. That cannot be simplified. Whoa, look how complex these are. 2 times 4 plus 3 times 16 squared all over 4 times 8 squared minus 2 times 4. All right, let's do 16 squared. I think I did 16 squared earlier. 256? 36, 9, 6, 1, 6, 5, 256, yeah. So let's get rid of this equal sign. Let's expand the page. Move that over. So we have 2 times 4 plus 3 times 256 over 4 times 8 squared minus 2 times 4. Let's do the multiplication left. That's 8 plus 3 times 256 over 4 times 8 squared minus 2 times 4. Let's do the product. We're going to multiply that by 3, which is 18, 16, 7. So 8 plus 7, 68 over 4 times 8 squared minus 2 times 4. Let's do the exponent. Oh, I probably should have done the exponent. Yeah. So we'll add these top two. That's 76 over 4 times 64 minus 8. Let's do the product. 776 over 64 times 4. 16, 24, 256. Minus 8, 776 over 256 minus 8 is 248. That's not doubled. It's not tripled. Is it tripled? Times 3? No, that would be 24. Okay, let's start reducing this fraction. 3, 8 over 1, 2, 4. And we get 1, 9, 4 over 62. And we get 9, 7 over 31. Is that it? 7, that's 16. Yeah, I think that's an ugly fraction. That's if I did all of this stuff correct. So more stuff, more places to make silly mistakes. But I got 97 over 31. Might be it, might not be it. That's a weird answer, but we'll see. 3 times A times B plus 16 squared. They like the 16 squared over 8. Okay, let's do 16 squared. 3 times 8 times 4 plus, what did we say, 256 over 8. And that's 24 times 4 plus 256 over 8. 24 times 4 is 64 plus 256 over 8. And that's going to give us 320 over 8, which actually simplifies to a nice clean 40. Let's go back to that. Did I do this correctly? That's minus. Yeah, that's good. A is 8. 2B plus 3C times 3 plus 8. 8 and 8 is 16. Yeah, 776. That's correct. 64 times 4. 256 minus 8. That's correct. Yeah, it looks like it's right. It's just sticking with me. I couldn't let it go. A over B, 8 over 4, quantity squared, minus 16 over 8 minus 4. So let's simplify in here. That's 2 squared minus 16 over 4. Let's do 2 squared, which is 4. 16 divided by 4 is 4. 0. Another good, clean answer. 2 times 8 minus 4 squared all over 8 times 4 plus 16 minus 8 over 4 squared. So let's do 2 times 8 is 16 minus 16 over 32 plus 8 over 16. That's 0 over 32 plus 8/16 can be simplified to 1/2. 0 over 32 is 0 plus 1/2 is 1/2. Another good, clean answer. I probably made a mistake then. 6 times 8 is 48 plus 3 is 51. That was way too easy after all those other crazy ones. That was weird. Again, 8 times 3 minus 6. 24 minus 6 is 18. 2 times 6 plus 3 times 8 minus 3. We're going to do 12 plus 24 minus 3, which is 36 minus 3, which is 33. 2 times the quantity, 6 plus 3 minus 8. We'll do 6 plus 3, which is 9. 2 times 9 is 18. Minus 8 is 10. We're rolling now, baby. These are real easy, nice, and simple. We're going to do inside So that's 2. We'll do 15 plus 2, which is 17. 5 times 6 minus the quantity 8 plus 2 times 3. That's going to be 30 minus 8 plus 6. 30 minus 14, and that gives us 16. 3 cubed plus 8 squared minus 4 times 6. That's going to be 27 plus 64 minus 24. 27 plus 40, which is 67. 8 plus 6 times 3 over 2. 8 plus 18 over 2. That's 26 over 2, which is 13. 3 times 8 plus 6 squared all over 3. That's 24 plus 36 over 3. That's going to give us 60 over 3, which equals 20. All right, now we're on to the word problems. Here we go. Jefferson High School has 100 less than 5 times as many students as Taft High School. Write an expression to find the number of students in Jefferson High School if Taft has T students. So it is 100 less than 5 times 5t minus 100. How many students are at Jefferson if Taft has 300 students? So we'll substitute 5 times 300 minus 100. So that's going to give us 1,500 minus 100. So there are 1,400 students at Jefferson. Guadalupe Peak in Texas has an altitude that is 671 feet more than double the altitude of Mount Sunflower in Kansas. Write an expression for the altitude of Guadalupe Peak if Mount Sunflower has an altitude of n feet. So Guadalupe has an altitude that's 670, more than double the altitude. So double the altitude and then add 671. That would be the expression. And then if Guadalupe Peak is 4,039 plus 671, let's double that, 18,708 plus 671, which is 9,478. 1,000 feet is the altitude of Guadalupe. Guadalupe Peak. 65. The Plaid Taxi Company charges $1.75 base fee plus $3.45 per mile. D'Angelo plans to take a Plaid taxi to the airport. Write an expression to find the cost of D'Angelo of n miles. So it is $3.45 per mile plus the base fee. And if he drives 8 miles, so 3.45 times 8 plus 1.75. So let's multiply 345 times 8 is 40, 32, 36, which is 24, 27, 2 decimal places. So $27.60 is the cost for the 8 miles, plus the base fee is 5, is 3, is 7, 8, 9, $29 total. It'll cost D'Angelo $29.35. The area of a circle given by the product of pi and the square of the radius. Write an expression for the area of a circle. Radius r, so pi r squared. And what is the area of the circle? Use 3.14, so we're going to substitute two values, squared. And so we have 3.14 times 49. And I guess we can do inches. Let's do this. We would need to use quantity. We can't write 7 inches squared. And this is going to be 49 inches squared, no parentheses. And now we're going to multiply 49 times 3.14. 9 times 4 is 36. 3, 12, 27, 28. Let's erase those numbers up on the top. And now move the decimal place, or move a place value. 4 times 4 is 16, which is 5, and 12. So 6, 8, 3, 5, 1, 2 decimal places. So it's going to be 153.86 inches squared is the area of the circle shown. I think we're good there. I trust my answer. Consider the expression 5x over 2 plus y to the third. Write two verbal expressions for 2. Evaluate the expression. Yuck. Okay. So the product of 5 and x divided by 2 plus 2 comma, it's one way of plus the cube of y. I'm only writing one verbal expression. I've written enough today. Evaluate the expression if x is 4 and y is 2. So 5 times 4 over 2 plus 2 cubed. That's 20 over 2 plus 8. That is going to be 10 plus 8, or 18. Evaluate 7 times 2 plus 6 over 6 plus 4. That's 14 plus 6 over 10, and that's going to be 20 over 10, or 2. 7 squared plus 6 squared plus 4, which is 49 plus 36 plus 4. That's going to give us 85 plus 4, or 89. 2 times 4 plus 6 squared all over 2, which is 8 plus 36 over 2, which is 44 over 2, which is 22. 2 plus 5 times the quantity, 2 times 3 plus 4. So 2 plus 5 times 6 plus 4, 2 plus 5 times 10, 2 plus 50, 52. Orders of operation, we do not add those. Addition comes last. We got to do that multiplication and the grouping symbols. Good tricky question. Write an algebraic expression that includes a sum and a product. Write a verbal expression for your algebraic expression. Includes a sum and a product. So 2 times the quantity, 3 plus 5 is the algebraic expression. And then the verbal would be 2 times the sum of 3 and 5. That's not bad. Right, a verbal expression includes a difference and a quotient. 6 minus 2 divided by 5. So the difference of 6 and 2 divided by 5. Oh, look at this. A toy manufacturer produces a set of blocks with edge B that can be used by children to build play structures. The product team is analyzing the amount of paint they need for a block. The production team decides to use one coat of paint for each block. Write an expression representing the minimum amount of paint needed for one block with edge B. Well, if it's a cube, the surface area, I don't know if you remember surface area, is going to be, we have 6 faces, so it's going to be 6 times b squared, because it's going to be b times b would give you the surface area of this face, and there are 6 identical faces. So that's why we can multiply it by 6. The production team decides one coat of paint is not enough. So they want to use 2 coats of paint for each block. Write an expression representing the minimum amount. So that would be 2 times 6b squared. The production team purchases cans of paint that will cover 60 inches square. Write an inequality representing the maximum length edge B in inches when the block is covered with the minimum amount of paint needed for 2 coats. So we're going to set this area needs to be less than 60. Okay. So that's going to be 12b squared needs to be less than 60. We can divide by 12. Are we solving? Are we writing an inequality representing when the needed to go? Okay, so we just wrote an inequality. Might be less than or equal to. Not red, black. We'll cover 60. Yeah, so 2 times 6b squared must be less than 60. That area needs to be less than or equal to, sorry. Good. During a long weekend, Devin paid a total of X dollars for a rental car so he could visit his family. He rented the car for 4 days at a rate of $36 per day. There was an additional charge of 20 cents per mile after the first 200 miles driven. Okay. Write an expression to represent the amount Devin paid for additional mileage. So, well, if he drove m miles minus 200, and then we're going to take that and we're going to times it by 0.2. So that is 20 cents per mile after the first 200. Paid for additional mileage, that's A. Write an expression to represent the number of miles over 200 miles that Devin drove. The amount paid for additional mileage, yeah. Write an expression to represent the number of miles over 200 miles that Devin drove. Well, isn't that the same? Isn't that just m minus 200? And how many miles did Devin drive overall if he paid a total of 174 for the car? How many miles? So we're going to say 174 equals 0.2 times the quantity m minus 200 plus 4 times 36, because it costs him $36 per day. Additional charge, yeah, there it is right there. How many miles did Devin drive you paid? Oh, so we got to do the math. Okay, we're going to do this one out. So 174 equals 0.2 m minus, oh, what's that? That's going to be 40? is 0.2. Let's look. 0.2 times 200 gives you 40. Good. Boom. So that's 40 plus 36 times 4 is 24, 144. So we'll add these two. So 174 equals 0.2 m. This gives us positive 104. Let's minus the 104. Minus the 104 gives us 70 equals 0.2 m. Let's divide by 0.2, 0.2. 0.2 divided by 70. Move the decimal point one place. We have to move the decimal point one place here. So that is 2 divided by 700. And that goes in 3 times 350 miles. So 350 equals m. So we drove 350 miles. Boom. Real good problem there. You got that right. That's pretty good. For the cube, x represents a positive whole number. Find the value of x such the volume of the cube is 6 times the area of one of its faces have the same value. What? The volume of the cube and 6 times the area have the same value. So the volume, which is big B times h, the base shape is a square, so s squared times height. So a side is x squared, a height is also x, so we get the volume equals x cubed. And the area of one of the faces is x times x, or x squared. So what? Oh, so 1. 6 times. So x cubed equals 6 times x squared. So let's divide by x squared. Let's get those variables on the same side. You get x equals 6. Is that correct? 6 cubed. Let's look at what's... So yeah, of course it is. Yeah, because that's 6 times 6 times 6, and 6 cubed is 6 times 6 times 6. Cool. Okay, so that was not as tricky. Find the value for x. Yeah, 6. Boom. Describe how to write an algebraic expression from a real-world situation. Include a definition of algebraic expression in your words. Nope. Not doing it. Explain the difference between algebraic and verbal expression. Nope, we're not going to describe that. Write a real-world situation that can be modeled by the inequality 10t plus 5.25 must be less than 50. You have $50 to spend on rides at an amusement park. The membership costs $5.25, and each ride costs $10. How many total rides T can you take? Yes, that's good. That's worth spending my time on. Boom. That's it. Okay. That was a good long one.